All right. So hi everyone. Happy Monday. So this is a session for Monday, and we will be discussing probability again. And hopefully we will move on to something called probability distribution, which serves as the foundation of probable. Foundation of statistics. And some of you have requested that we do some kind of research because this course obviously is statistics and research methods class. Um, However, the only problem that I'm having with this class is that we were supposed to finish everything that we've done so far within a week and a half, and that was my plan for this class. Um, because when we're doing some kind of research, we need to do something called hypothesis testing, right? And that comes I'm not even sure if we will have time to cover those topics, but that's something that we need to cover in order to do some kind of research, because whenever we're doing some kind of research, we're pretty much testing, oh, if this is true or not. And if we're doing some kind of research based on the data that we have, we are going to draw some conclusion. And drawing conclusion and analyzing those data, we need to use um, hypothesis testing, or sometimes we need to use normal distribution. And those topics we did not have time to cover yet. So as far as research part is concerned, I'm not sure. I cannot promise you if we will have any opportunity to do some research. Um, and for the final project as well, because that's something that we needed to I well that's something that I wanted to do um, after going over those topics, but at this point I'm not sure if that's even possible. So we will just continue with it. Monday is 21st. We have this week and next week as well. So it's going to be this week Monday through Friday, and next week Monday through Thursday. Alright, so that's pretty much our plan for now. Um, we'll just continue with the statistics that we've discussed. And if you want to do any kind of research in specifics, for example, if you wanted to do some kind of business analysis, just let me know. And if let's try to find something that's relevant for us that we can discuss. But I'm not guaranteeing that this is going to be a research research opportunity per se, but we can definitely include some kind of data analysis, or how we can read those data. Um, at this point, I think that's the best option for us if you want to do some kind of research. Um, and I guess as far as research part is concerned, we can definitely talk about sampling, like um, how to sample a population. So, for example, if you're doing a survey, or if you're targeting a population, what is the best way to um, get a sample that's representative of the population, something like that. Or bias, like what kind of biases are there that we need to avoid when we're doing research and when we're doing some sampling. Those topics we can definitely cover. So if you want to do that, just let me know. That's not going to be some uh, that doesn't necessarily mean that we're going to conduct a research, but that's like that serves as a basis for conducting a research. So being aware of those topics and having the knowledge, it definitely makes a difference. So just let me know if you're interested, okay? And we can definitely cover those topics, because that's not something impossible to do at this point, right? So Alright, that's that, and we are going to move on to this is this is one of the more fun topics in statistics because probability is it's a lot of fun, to be honest. A lot of calculation and a lot of thinking, but however it's interesting because there are a lot of different ways of solving the problems, right? So today we're going to talk about something called permutation and combination. And I believe this was on the quiz, the assessment that we had when begin. I think it was the first day of class. Yeah. So this is the quiz that we had, and I briefly mentioned something about permutation and combination, and we discussed the n choose r. What else was there? Factorial, right? So we're just going to cover the basics, and we will move right on to probability distribution. Right? So, um, all right. So permutation and combination, these are all for counting, pretty much. Okay. So let's just look at a really simple principle. So if there is a procedure that can be performed in uh, um, so to say n sub 1 ways, right? So one process can be performed in n sub 1 ways, all right? And the second procedure can be performed in n sub 2 ways. Okay? And in total we have n sub 1 times n sub 2. This is a basic. This is something that we use over and over again and we are very familiar with it. So that's a basic counting principle, right? For example, um, say here we have A, B, and C, and um, there are I don't know, there are 5 ways of going from A to B, and there are 3 ways of going from B to C, and in total there are 5 times 3, which is 15 ways of going from A to C. Correct? So this is a very simple example, showing you how we can use those principle. All right. So why don't we work on some examples because these are pretty easy. These are simple counting problems. Okay. So let's look at an example. Trying to find a good one, but I only see really simple ones. Yeah. Um. Okay. So this is the uh permutation. I guess we can use this as an example, and we can just move on to permutation because those type of questions seem way too easy for us. See, so permutation is pretty much arrangements. Okay? So this is when the order matters. Okay? For example, um so say that there are okay. So say that there are we're looking for the number of lineups for 9 players of a baseball team. Alright, so we're looking for the order, the arrangement of 9 players in total, and we're looking for the number of ways we can make those, right? And of course, we would use what 9 factorial for this. That's going to be 9 times 8 times 7 dot 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 times 2 times 1, right? And we call that permutation. It's um, when we are looking at the arrangement of the order, right? The number of ways we can arrange something. Okay, so that's permutation. Um, Alright, so another thing. Okay, let's just go over the topics first and then we'll look at specific example if we need to. So permutation was that, and we're looking at combination now. Okay. Okay, combination is pretty much the number of choices, so not the number of possible choices. Okay. Of R objects from a group of n distinct objects. Okay, and we denote this by okay or n choose. Okay, and this is n times n minus 1 times dot 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 n minus r plus 1 over r times r minus 1 dot 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 times 2 times 1. Okay, so this is a combination. So let's look at an example. Okay, so here is an example that I chose. Let's read the problem first. There are 5 qualified applicants for 2 editorial positions on a college newspaper. 2 of these applicants are men, 3 women. If the positions are filled by randomly selecting 2 of the 5 applicants, what is the probability that neither of the men is selected? Alright, so um, first things first, we have to notice that this is where is it? It's a random selection. So everyone has an equal chance of getting selected. Alright, and we know that out of these 5 applicants, 2 of them are men and 3 are women. Alright, and we're looking for the probability that neither of the men is selected. So when we are picking 5 of them, we're saying that there are both women. Alright, so that's the probability that we're looking at. And again, the formula for probability is as follows. We're looking at the specific event over the sample space, right? So specific event over sample space. So for example, sample space is every possibility of picking 2 out of 5. Alright? And again, one thing to notice is that here we're going to use combination instead of permutation, because does the order matter? Let's just think about this. If there are 2 editorial positions, right? these two positions are equivalent. So it doesn't matter if A and B are selected or B and A are selected. Doesn't matter because they serve the same position regardless. So AB equals B and A. So we, in this case, we would use combination because we're not really concerned with the order and the timing of the event. Okay, so so the sample space will be everything, counting like how many ways are there possibly to pick two people out of 5, right? So that will be our sample space, and we denote that by this combination thing that we just learned. So it's going to be 5. Oops. It's going to be we're picking out of 5, so it's going to be 5 out of 2 because that's how many positions that are being replaced. So let me just, so that will be it'll be 5 choose 2, right? So again, that will be the sample space because we're looking at the total number of ways of doing this. So that's the sample space, and specific event would be that neither of the men is selected. So we're choosing between the rest of them, rest of the people other than men. And again, so out of these 5 people, 2 are men and 3 are women. And we want to choose 2 people out of these 3 women, right? So the specific event in this case would be 3 choose 2. Okay, do you follow? Because we want them to be all girl, not men in any case. So we're picking out of the rest of the people other than men, so that would be 3 women and choosing 2. Okay, and to evaluate this, we do have a formula that looks like this, but it's a lot simpler than this. So we're using, again, this example. If we're doing 5 choose 2, that will be, okay, let me just write this down here. 5 choose 2 would be 5 times 4 over 2 times 1. Okay, because well, if you're thinking about it in terms of the logic behind this, this is where we have 5 and we're choosing 2, right? So 5 times 4, but you can have 2 different combinations. So you can either have A or B or B or A. So you have to divide it by the number, which is 2 times 1. Okay, so what is this? This would be 10. And same thing here, 3 choose 2 is 3 times 2 over 2 times 1, so this is simply 3, right? So the probability in this case would be 3 out of 10. Okay, so let's look at another example. Alright, so here's another example that we can look at. So it says how many different poker hands meaning 5 cards, can be selected from a deck of 52 cards. Okay, so pause the video, just think about it, give it a moment, and come back to it. Alright, so um, we're looking at this problem, and again, here we would have to use combination. Why is that? Well, because when we're choosing a poker hand, we're we're not looking at the order. So say you got um I don't know, A, 2, 3, 5, J, 2. Right, so you got, say that you got these, and having different order, so having different arrangement of this wouldn't make any difference, right? Doesn't matter if you get the 2 first or if you get the 5 first. As long as you have these cards, right, these hands, then it means the same thing. Right, so we're choosing 5 cards out of 52 cards. So this is simply 52 choose 5, right? And this can be notated as 51, 50, 49, 48 over 5 factorial over 5 times 4 times 3 times 2 times. Okay? So this would be the different ways in which you can make um, poker hands. Okay? Alright, so I included 2 extra examples, and it might be more than 2 because there are more than one part to the second problem, but here are the examples that we can go over. So pause the video and work on these problems. If you are stuck, just let it pass and work on the other ones first, and then come back to it once you're done. Okay? Okay, so I'm guessing you're all done with the example, so let's go over it. So it says 5 cards are selected from a deck. What is the probability that exactly 2 kings are chosen? Oh, it should be chosen instead of chose. Let me just fix that up. Alright, and this is very similar to the problem that we did before. So again, for any type of probability, it's going to be a fraction. So it's going to be the specific event over the sample space. And in this case, the sample space, what is the sample space? Well, sample space is when choosing 2 Alright, so sample space again is choosing 2 cards out of a deck, from a deck, 52 cards. It's very similar to the question that we did before, so it's going to be specific events. So let's just label this 2 kings, choosing probability of 2 kings over choosing 2 cards from a deck. So choosing 2 cards would be 52, choose 2 again, and choosing 2 kings, what is that? How many kings are there? There are 4 kings, and we want to choose 2 kings in total. So that's going to be a very slim chance. 4 choose 2. And again, you can rewrite this as 52 times 51 over 2 times 1, right? That's on the bottom. On the top, it's going to be 2 times 1 over 2 times 1. So 2 times 1 cancels out. And what do you have? And you have 2 over 52 times 51. Right, so that was the example. That's one of the easier ones. And here, let's look at the problem. Right, a group of 52 people consists of 2 people whose names begin with B. 5 people from this group are chosen. Find the probabilities associated with the following events. And there are 6 more cases that you need to consider, so let's just do it step by step. Okay, so we're looking for the probability that the final event happening, and it's going to be 2 A's, 2 B's, and 1 C. Alright, there was a typo in the question, so just to clarify that there are 26 alphabet letters, and each letter name has 2 people with the starting letter of each letter. It's confusing. So, for example, there are 2 people with whose names begin with A, and 2 people with B, 2 people with C, so on and so forth until Z, okay? And 5 people from these groups are chosen. Okay, so first of all, we're looking at this probability, right? Which is 2 with A, 2 with B, and 1 with C. Okay? And again, we're looking at this probability, so we have to decide on the sample space. And sample space would be choosing 5 people out of 52. So that's going to be 52 choose 5. Right? This is the sample space. And we're looking at 2 A's, 2 B's, and 1 C. And there are 2 A's, right? And there are 2 A's, and we're picking 2 out of them, out of the 2. Again, we have 2 B's, and we're picking 2 B's out of 2. And we have 2 C's, but we're just picking one of them. So this would be the probability. And as you can see, this is going to be a very, very low number, because you have 2, and how many cases are there that you can choose 2? So it's just 1. You have to choose that one. So this is essentially 2 choose 5, and then 2 choose 2 is 1, 2 choose 2 is 1, and 2 choose 1 is what? Is 2. So this is going to be 2 over, where's my pen? Right, so it's going to be 2 over 52 choose 5. Okay? And next is when we have 5 vowels. Vowels, let me just write these down. Vowels are A, E, I, O, U. Okay? So, again, sample space would be 52, choose 5. And on the top, you can have any of these, right? And each of these letters have 2 people. So A has 2, E has 2, I has 2, O has 2, and U has 2. and we want just any of them. So in total there are 10. Okay. So in total you have 10 and you're choosing 5 of them. Correct? Because this is the pool of possibilities that we're choosing from, and there are 2 of each, so 5 times 2 is 10, and then we're choosing any of the 5 out of that. So that's going to be our probability. And if you write this out, the bottom part cancels out. So for example, 9, 8, 7, 6, and then down we have 5 factorial. And you have 52, 51, 50. Okay, again 5 factorial. So these cancel out. So the answer is over 52, 51, 50, 49, and 48. So this would be your answer. Okay. So part C, everything else is fine except for having a Z. Okay, so no Z. How many cases are there without Z? Well, there are 26 alphabets, but without Z, that's going to be 25, and there are 2 of each, so, oops. Okay, so there are 50 of them. Let me just erase this first so I don't get confused. Okay, so there are 50 in total. And how many are we choosing? We're still choosing 5 of them, right? Over sample space stays the same. So this would be your answer. And if you write this down, the 5 factorial on the bottom will cancel out and you end up with this. But however, if you look at it closely, you'll see that these are all repeated. From here on, so here on. So I would say the answer is this. Okay. So let's look at exactly 3 consonants. Okay. So consonants are selected random, right? Exactly 3 consonants with meaning that the rest 2 will be vowels. So write it down. It's going to be, where's my pen? 3 consonant and 2 vowels. So that's going to be, how many consonants are there in total? Well, we already established that there are 5 vowels, so 5 vowels, and this is going to be 10 names that starts with vowel and the rest. that will be 42 names that start with a consonant. Right? So exactly 3 consonant means we're going to choose out of these 42, we're going to choose 3. And the rest, I have 2 more. And I'm going to choose that from vowel. And we only have 10 vowels. And again, the sample space is 50. 2 choose 5. That will be the answer for part D. Okay, so for complicated ones like this, you don't really have to multiply out because we're only looking at the formula and if it makes sense. Okay. I think there was a mistake because D and E sound the same. So let's just skip this part. Yeah. And we're moving on to this part. A, B, C, D, and E. Okay? So, A, B, C, D, and E, they all have 2. And we're choosing one from a 2 card pool. So if you're to write that down, that's going to be 2 choose 1, 2 choose 1, 2 choose 1 over 52 over 5. So again, 2 choose 1 is simply just 2. And we're multiplying this 5 times, so that's going to be 2 to the 5th power over 52, choose 5. Okay, so here is the end of combination and permutation chapter, and I think you will be doing this in class. So I've created the class worksheet for you, so just work on it together. Even if you didn't do any of the work before for this chapter, I'm pretty sure you are able to, because you all have knowledge and backgrounds in math. So just try it and discuss it as a group. And I will see you at the Q&A session. So this is it for today. And if you have any questions, just write it down or let me know during Q&A session.